Hello, this is Mr. Agbamu Idanogrenen. I'm here to teach mathematics and I'm going to teach you the topic matrices. In my topic for today, I'm going to focus on these objectives. I'm going to focus on perform operations on scalar multiplication of matrices, then perform operations on multiplication of matrices. So these are the two aspects of matrices I want to focus in today's class: scalar multiplication and multiplication of matrices. Okay, let's continue. Now, what is scalar multiplication in matrix? So scalar multiplication is just like in mathematics when you have two numbers multiplying each other. For example, if I have something like this, let's say 2 times 3, let's say 2 times 3, and you're going to get 6 as your answer. So these two numbers multiplying each other. But in scalar multiplication, you are going to have a number multiplying a matrix. So not just a number multiplying a number. So that is just what scalar multiplication is talking about. You have a number and that number is called a scalar. Because in your basic science, in your physics class, you will discover that when we talk of scalar, we are talking of a quantity that have no direction. So that number is a scalar. We don't know the direction, but we know the size. We know the size of the quantity. So that's why we said if A is a matrix, you see it, if A is a matrix and K is a constant multiplying A. See, so this K is a constant. So a constant is always a number in mathematics. So this constant can be 2, it can be 3, it can be 10, it can be minus 12. But K is a constant, is a number, and it's multiplying this matrix A. So this K is what we call a scalar, this constant number. So and I say then the matrix Ke is called the scalar product. You know, when two numbers multiplies each other in mathematics, we say they are product. So A times B, we say the product of A times B. So that's why we call Ka as the scalar product of the matrix A. But the constant is the scalar, while the matrix is the second number. For example, let's look at this example we have here. We say let X be this matrix, that S is equals to matrix 4 minus 11 minus 83. So this is a matrix. Then we have another matrix, matrix Y, which is minus 5, 1, 0, and 6. So this is another matrix labeled as matrix Y. Now this is what they say we should find. Say we should find 2x, which is 2 times x. So this 2 is a constant. So this 2 is a scalar. You can see it. So 2 is a constant, which is the K, and it's multiplying a matrix. For example, in this case, the matrix is X. So 2 multiplied by matrix X. So will now give us our scalar multiplication. The same thing with the second question here. It says minus 3 times Y. So minus 3 is going to multiply this matrix Y. Then the same thing here. Now that you already know how to add matrix, subtract matrix, multiply matrix, you can do this third one, which is 4x. 4 is a scalar multiplying this matrix X. Then whatever answer you have, you subtract 2 scalar multiplying matrix Y. That's all we are going to do in this particular scalar multiplication. Okay, let's go straight to the solution. Let's see how we are going to solve it. So it's not a difficult thing. All you need to do is, let's write our solution down. Solution. So all you are going to do here is, you already know X as this matrix, and A, that is the first question. I say we should find 2x. So just go straight to the point. So I says we should find 2x. So 2x will now be equals to 2. Put the 2 down first. 2 is multiplying. So 2 times, you put your matrix. 2 times matrix X, which is 4 minus 11 minus 8 and 3. So that is it. Let me position it well. Okay. So that is it. So 2x. The first question we are calculating is 2 times matrix x. So it depends. You may even ignore this multiplication symbol. You can decide to write it like this. You will still get the same result. So 2x is equals to 2 multiplied by the matrix. Then our answer is going to be, let's put our answer down. Our answer is going to be 2x going to be equals to. So what are we going to do here? All we are going to do here is very simple. Just like opening of bracket, the scalar number outside is going to multiply each element of this matrix. Remember what I said the other time, the numbers inside matrix, we call them element of the matrix. So this number, which is the scalar constant, the number here, will multiply each element in the matrix. That is all we do in scalar multiplication. There's nothing there. Just multiply them and that is all. That is the answer. So 2x is equals to, so you start with 2 times 4. Okay, let me just do it step by step so that we can follow with this first example. So 2 times 4. Then you move to the next one. 2 times minus 11. 2 times, then the minus, put it in bracket, it's very important, minus 11. Then 2 will still continue, 2 times minus 8. So 2 times, put the minus 8 in bracket, 2 times minus 8. Then finally 2 times 3. This is 2 times 3. Then your answer is now going to be 2x now be equals to 2x will now be equals to, so 2 times 4 will give us 8. Then 2 times minus 11 will give us minus 22. Then 2 times minus 8 will give us minus 16. Then 2 times 3 will give us 6. So that is the answer of I. Very simple as that. So this is what we mean by scalar multiplication. The constant, which is called the scalar, is going to multiply the matrix. So seeing the matrix is x and the constant is 2. So we do it like the way we do opening of bracket. So the constant outside the bracket will multiply each of the elements inside the bracket. That is all about scalar multiplication. So let's just complete these other ones. Let's see how we are going to do it. So the second question here is minus 3y. So minus 3y is going to be equal to, so the matrix y is minus 5. Then okay, let's put the minus 3 out first. Minus 3 multiplied by minus 5, 1, 0, 6. Then the next step is minus 3y is equal to, let's get the matrix, is equal to, so minus 3 we times each of these elements. So that is all we are doing. So you can move this step the same way I did this, or you just multiply direct and get the answer. So let me just do it directly because of time. Minus 3 times minus 5 will give us plus 15. Minus 3 times 1 will give us minus 3. Minus 3 times 0 will give us 0. Minus 3 times 6 will give us minus 18. So that is the answer to the second question. And this third one, we need to do it step by step. You need to find 4x first, then find 2y, then you will now subtract the two answers using subtraction of matrix. Let's do it also. Let's see how it goes. So we have the third question, which is 4x. So 4x minus 2y. 4x minus 2y. This is now going to be equal to, let's get our matrix. So 4, okay, yes, 4x. So the first matrix here is 4, 4 minus 11 minus 8, then 3. So don't forget, 4 is multiplying this matrix, which is 4. You put 4 outside, then we continue, minus, second matrix is 2. You put your 2 there, then you get your matrix 2. Then the matrix 2y now, matrix y is minus 5, then 1, then 0, you have your 6. So take note of this. Let me move up a little. Okay, so now that we have this, let me position it. Okay, now that we have this, our answer will now be what now? We open the bracket first, do the scalar multiplication before you subtract the matrix, which is 4x minus 2y will now be equals to, so when you multiply 4 with the matrix x, which is 4 times 4, is going to give us 16. Then 4 times minus 11 will give us minus 44. Take note, this constant is multiplying each element. Take note, that's what we are doing. So 4 times 4 is 16. 4 times minus 11 minus 44. Then we are now here now. 4 times minus 8 will give us minus 32. Then 4 times 3 is going to give us 12. So that is the end of the first application. Then we have minus, then 2 is going to multiply this matrix. So let's put the bracket there. Okay, so you start, please don't multiply with this minus outside. Leave the minus because the question says 4x minus 2y. So don't use this minus 2 times. Leave the minus. Just take note of that. Leave the minus. So it is only 2 that will multiply each of the element in this matrix. So this one will give us minus 10, which is 2 times minus 5, minus 10. Then 2 times 1 will give us 2. Then 2 times 0 is 0. 2 times 6 is 12. Okay, so now let's go to our final answer. So 4x minus 2y will now be equal to, now let's position it well. Remember, we are subtracting corresponding element. So this is 16 minus 10. So don't forget that 16 minus this minus is this minus, then minus 10. Put the minus 10 in bracket. Minus 10. Then let's go to the next element, which is minus 44. Minus 44 minus 2. We'll come here. Minus 32 minus 0. Minus 32 minus 0. So minus 32 minus 0, then 12 minus 12. 12 minus 12. Okay, I position it well. Okay, so now finally we have 4x minus 2y now be equal to, let me position it well, now be equal to, let's get our matrix. So minus times minus here will give us plus, which is 16 plus 10. I'm going to get 26. Then minus 44 minus 2 will give us minus 46. The minus 32 minus 0 will be minus 32. And finally, 12 minus 12 is 0. So this is the answer. So take note of that. So this is the solution to this example that we have here in scalar multiplication. So x is this, y is this. So 2x, what scalar multiplication says we should do is 2 constant will multiply the matrix x, minus 3 constant will multiply the matrix y. Then in this case you multiply 4 by matrix x, then you now subtract the answer of 2 times matrix y. Solve it very well. So this is the solution. Let me move it up. So this is the solution of that example. Okay, let's go to multiplication of matrix before we go for today. Okay, now this is multiplication of matrices. So in multiplication of matrices, all you need to do in this case is check the condition, which is very, very important. We don't do corresponding elements in multiplication of matrix. In multiplication of matrix, you need to check this condition first. We said two matrices A and B can be multiplied if the number of columns of the first matrix A. So what we mean by this is the first matrix that is multiplying the second matrix. For example, this example we have here says A times B. So A is the first matrix. So because A is multiplying B, take note. So we said if the number of columns of the first matrix A is equal to the number of rows of the second matrix. Let me get my blue pen so that we can get it very well. It says if the number of columns of the first matrix, so this is the first matrix. This is the first column, 1, 2. First matrix have 2 columns. So it said if the number of columns of the first matrix, this is the first matrix that's multiplying this, is equal to the number of rows. So we count the number of rows of the second matrix. See, 1, 2. So if number of columns of the first matrix is equal to number of rows of the second matrix, then this matrix is possible for multiplication. But if they are not equal, you cannot multiply them. You can see it. First, second column in matrix A, 2 columns. In matrix B, 2 rows. Then this matrix can be multiplied. Please take note of this very important condition. Okay, let me just show you something so that you see what we are saying. Let me take, for example, this is 2 by 2 matrix. Let me demonstrate something for you here. You see what my system will tell us. Let's say I have a matrix 2, 8, 9, let's say 3. Okay, for example, let's say I'm multiplying, let's say multiply by, let me put another matrix. Let me take this. Okay, let me undo this. Okay, let me take, for example, this matrix. Okay, let's say this is 3, 4, let's say 9, minus 5, 6, let's say 1. For example, I want to multiply these two matrices now. These two matrices. If I press my equal to, you see what the system will tell me. See, it highlighted with red color. These matrices are not compatible for multiplication. If you can see this little statement here, you say these array dimensions do not match. See, this matrix do not match. That is, the order of the matrix do not match. Remember, I told you order of a matrix and dimension, they are the same. That's why the system cannot solve it. And why can't the system solve this? Is because from the definition or from the condition for multiplication of matrix, it said the first matrix, check the number of columns. So if the number of columns of the first matrix, so this is the first matrix, it has 2 columns, 1, 2, must be equal to the number of rows of the second matrix. So how many rows do we have in this matrix? 1, 2, 3. See, so we have 2 columns, 1, 2 columns. This is 3 rows, so they are not equal. As long as the number of columns of this first matrix is not equal to the number of rows of this second matrix, then you cannot multiply this matrix. It's not possible. So take note of that. But if you want them to be possible for multiplication, then make sure the number of columns is equal to the number of rows. So take note of that. Let me put it so that you see. So if I have a matrix like this, let me do something like this. If I have 4, 6, 1, 3, 4, 5. So if you look at this matrix, you will see that we have 2 columns, 2 rows. So this matrix is compatible for multiplication. If I press my equal to, you see to give an answer. You see? So it's possible to multiply this matrix. So that's why we say for you to multiply 2 matrices, the number of rows of the first matrix must equal the number of columns of the first matrix must equal the number of rows of the second matrix. So take note of this. But how do you do this multiplication? You need to get the rules, which is very, very important. So let me demonstrate it with my software. I want you to follow this demonstration very well, because if I explain it here, you may not be able to understand it better. Let me demonstrate it with this software I have here. I want you to listen and watch the way I will do it. So you see these 2 matrices here, 1, 2, 3, 4. This is the first matrix. It's multiplying the second matrix, 5, 6, 7, 8, 9, 10. So this is the same example I have here. This is the same example I have here. But I want to demonstrate it in this side so that you can follow it very well. So let's start. Okay. So the first thing you do in your multiplication of matrix is this. You check the first row of the first matrix. You use it to multiply the first column of the second matrix. And this is how you do it. Let me get my pen so that I will follow very well. You can see the system highlight this place as red. First row, you highlight it as red. The first column of the second matrix, you highlight it as blue. So what it means is that this number is going like this. If you go like this and come down like this. Let me put the arrow head. So when this number goes like this and come like this, so 1 is going to be here, then 2 is going to be here. Then you are going to multiply them. Take note. So when you move this first row, when you move this first row like this and come down, you see 1 will multiply 5, 2 will multiply 8. So that's how we do multiplication of matrix. Let me show you what we are going to get. Just watch. So in this place you see 1 times 5. You can see it now. So 1 times 5, then you add it to 2 times 8. Then whatever you have, you put the answer down. That will be the answer for the first element in the multiplication. Please take note, it's very, very important. Take note of this procedure. 1 times 5, 2 times 8. Add the answer and write it down in your next line. And this is how we move. You move like this and you come down. So this will come down, 1 will come up. So take note of this. Okay. Then in the second stage, we do the same thing. We are not through with the first row yet because we have now multiplied second column and third column. So the same thing, this first column will still go again and multiply the second column. This first row will still move and multiply the second column, and we move in this order. So 2 will also come down. So 2 times 9. Then this is 6 times 1. So take note of this. 2 will times 9, 1 will times 6. So you continue the operation like that. 1 and 2 will still move again until you complete the column. We still move on like this. So just follow the rules. So 1 will times 7. Have 1 times 7. Take note. Then 0 times 2. Then you add them. You write the corresponding answer on this place. Write this one here and write the other one here. So how do you do that? Let me show you with the animation I have here. Okay, you can see it now. You can see it. Okay. So you can see it now. So 1 times 6, then 2 times 9, then you add it, you are going to get 24. So 1 times 6 is 6 plus 2 times 9 18. So 6 plus 18 will give you 24. The same thing here, 1 times 7 plus 2 times 0. So you get it 1 times 7, 2 times 0 will give you, when you add it, you will get 7. So that is for the first row, multiplying the columns, column 1, column 2, column 3. Then you do the same for the next column. For the next column now, this 3 and 4 to go like this and come down like this. Take note. It's always coming from up downward. So when this one rise up, it will rise up like this and come down. This is what we are talking about. So when it goes like this, 4 will goes up first, 4 will come down. So this one will give you times 4. Take note. Then this will give you times 3. So this is what we do. Then process continues again to the next column, continues like that. This will give you times 3, and this will give you times 4. Very, very important. Take note, you add then, the answer will be in this place. You times this one, 5 times 3, 8 times 4. You write the total answer here, just like that. Then the last stage, 4 and 3, this row will still go around. It will go straight and multiply this one also like this. So 4 will come down first before 3 will go up. So this will give you times 3, and this will give you times 4. And when you multiply them, you add them, you write the corresponding answers here. And that is all about multiplication. Just settle down and understand the process, and you'll see that it's not difficult. Let's watch, let's complete it. So you can see it. You can say 3 times 5 plus 4 times 8. Write the answer down. See the next one. 3 times 6 plus 4 times 9. Write the answer. Then finally you have 3 times 7 plus 4 times 0. You write the answer down. So please take note of the movement. It's very, very important. 4 and 3, the second row, we go and multiply the first column. So 3 will come up times 4 will come down. Then you add it. You write the answer here. 3 and 4 will still move again to the second column. 3 will be up, 4 will be down. You multiply them, you add them, you get this. Then 3 and 4 will still go again to the last column. 3 times 7 plus 4 times 0. So that is what we have here. I want you to take your time and understand it very well. You see that multiplication of matrix is not difficult. Just for you to understand the step, and you see that it's very easy. So with this principle, you see that you can multiply matrix. First row times first column. First row again times first column. First row times third column. You continue until the columns are finished before you go to the second row in the first matrix. Second row, first column. Second row, second column. Second row, third column. If you go through this calculation here, you see that what we did. You can see 1, 2, 1, 2, they're always there. 1, 2, that is the first row multiplying each of the columns. Then 3, 4, 3, 4, 3, 4. That is the second row multiplying each of the columns. Then you add the answer and write them down. That is what we do in matrix multiplication. So you can see the answers are 21, 24, 7. This is if you multiply these two matrices, since have explained it with the animation there, let me not waste time. If I multiply these two matrices A times B, our final answer is going to be, let me get the answer. Final answer is going to be 21, 24, 7. Have 21, 24, 7. Then the last rows is 47, 54, 21. 47, 54, 21. 7, 54, 21. So I think it's okay. I think you understand it very well. It's not difficult. That is all we do in multiplication of matrix. And that is all for today's class. I hope you enjoyed today's class. I want you to go through the lectures again. Let me just revise what we did today. We started with scalar multiplication. We said you have a constant number called the scalar multiplying the matrix. Each of the constant will multiply each element in the matrix, just like that. That's what we do in scalar multiplication. So take note of that. Hope you can see it clearly now. And each of the number will multiply, the constant outside will multiply each of the elements. You get your result. So take note of that. Okay, then let's see the multiplication of matrix. So we explain it by saying the row will multiply the column. Let me show you the animation again so that you understand it very well. First row times first column. You can see the first row 1, 2, multiplying first column, first, second. You add them, you write the result. First row again, second column, 1, 2. You can see it 1, 2, 6 and 9, second column. First row again, third column. You can see them 1, 2, 7 and 0. After multiplying each, you add. That is the end of the first row. The second row, you go again. Second row times first column, which is 3 and 4. 3, 4, multiply them. Then continue again. Second row, second column, which is 3 and 4 again. You can see 3, 4. Times then the last row, which is 3 and 4 again. Multiply the last column. You can see 3, 4. Last column. When you understand this principle, you see that multiplication of matrix is very simple. As long as the number of rows of the first matrix is equal, as long as the number of columns of the first matrix is equal to the number of rows of the second matrix, then multiplication is compatible. Okay, just practice this assignment I have here. Just practice these two questions and exercise yourself and see how you understand it. So this is matrix A and B. Let's see. We have two columns, 1, 2. And here we have how many? Sorry, yes, we have two columns, 1, 2 columns. And here how many rows? 1, 2. So this matrix is compatible for multiplication as long as the number of columns is equal to the number of rows. So you can multiply this matrix. Remember the rules: first row, first column, first row, second column, first row, third column. You are through with that. You keep the answer on one row. Then you move again. Second row, first column, second row, second column, second row, third column. Keep the answers in second row. You just follow the rules from that animation. You add them. Then finally, third row, first column, third row, second column, third row, fourth column, the same thing. Then when you want to do B times A, remember B will now be the first matrix. So you count how many columns in B, 1, 2, 3. So how many rows in A, 1, 2, 3. So this matrix is compatible for multiplication. First row, first column, first row, second column. Just settle down and practice it. It's not a difficult. Then this one is also a good one for practice. So you have two matrices M and N. When you multiply them, this is your result. But two unknowns are there, N and X. So they want us to find it. I want you to take your time and go through the lecture and follow the example very well. You can solve this assignment. So have a nice day. Thank you for listening.